Hi everybody. In this lesson we want to look at subtracting rational expressions. Now subtracting fractions and rational expressions is very similar to adding rational expressions or adding fractions. You of course need a common denominator. The only difference and one that's important for students that they often make mistakes in regard to is that when you subtract, you'll notice here in our first example, this has a common denominator, but when you subtract, you have to subtract this whole numerator, which means you end up distributing that minus sign to each of the terms there. Okay, so what I've got here in slow motion is 3a minus 2. I have this numerator minus this numerator all over that common denominator. Alright, so I have to distribute the minus sign both to the 4a and to the negative 7. So that's going to give me 3a minus 2 minus 4a plus 7 all over the a squared minus 25. So notice this is going to give me a negative a plus 5. Let me just write that as 5 minus a all over, and notice that I've got an a squared minus 25, which is the difference of squares. I can factor that as a plus 5, a minus 5. Now 5 minus a is just a minus 5 with a minus sign in front. I can factor a negative out of that, and then that a minus 5 is going to cancel with the a minus 5 in the denominator. Okay? Now commonly when you see this, once you understand that's going to happen, you could have at this stage just canceled those and just leave a minus sign, and you can see why that will work out. So my final answer here is going to be a negative 1 all over a plus 5. Okay, so remember when you're canceling, you really have a understood 1 that's left here. Okay, so let's move on to another example, t squared plus 3 over t to the 4th minus 16. Here I have the 16 minus t to the 4th, which I recognize is just the same as this with a minus sign in front of it. So what I'm going to do, I'm going to write this as t squared plus 3 over t to the 4th minus 16. And then I'll factor a minus sign out of this, t to the 4th minus 16. That will magically turn that around so it's the same as this, and just double check it. Right here's the negative t to the 4th right there, and then the negative 16, that makes 16, which is right there. Now what I can do with this minus sign, and let me just highlight this, that if I have for example negative 8 divided by 4, that's of course negative 2, that's the same thing as a positive 8 divided by negative 4. It's still negative 2. And that's the same thing as taking 8 divided by 4 and just putting a minus sign in front of it. Either way you get negative 2. So when I have a negative in the denominator like this, I can just bring it up and just think of it as subtraction. So this really is a subtraction problem. I got t squared plus 3 over t to the 4th minus 16 minus 7 over t to the 4th minus 16. Alright, so from there I will go ahead and subtract. So I take this numerator, I've got this numerator minus this numerator, now I have a common denominator, so this is going to be t squared minus 4 over t to the 4th minus 16. And I see I have a difference of squares here. I could also factor this as t plus 2 and t minus 2, but actually I can just leave it as t squared minus 4, because this is going to factor as t squared minus 4 times t squared plus 4, and then you can see that the whole t squared minus 4 is going to cancel, leaving me 1 in its place, and so I'll get 1 over t squared plus 4. Okay, and if I wanted to be very careful with my domain, I would note that in canceling this, that t could not equal either plus 2 or minus 2. because in order to cancel those, I'm assuming that this isn't 0 over 0, which doesn't equal 1. In any other number divided by itself is 1, but 0 over 0 is not 1. So I may want to make that note there. All right, let's do another one illustrating this process. I've got 4x over x squared minus 1, which I recognize is a difference of squares. I'm going to have to get a common denominator, so I'm going to factor here. I got 4x over x plus 1, x minus 1, and I've got an x 1 minus x. I'm just going to invoke this trick that we did in the other one. I'm going to leave room in case I need a common denominator there. And I'm going to factor out a minus and put it up front. So this will be 3x over x minus 1. All right. And then I'll leave another space here in case I need a common denominator here. And you can see my common denominator is going to be an x plus 1 times x minus 1. All right. So I don't need anything extra here, but for each of these I do need an x plus 1. All right, so from here, I've got this numerator, 4x, and then I have minus this numerator, so it's minus 3x times x plus 1, and then I have minus this numerator, that's minus 4 times x plus 1, and that's all over my common denominator, x plus 1 times x minus 1. So let's go ahead and distribute. So I've got 4x minus 3x squared minus 3x, and then here I'll get minus 4x minus 1, or I'm sorry, minus 4 when I distribute the 4 there, and then all over the x plus 1, x minus 1. So let's go ahead and notice there's a 4x minus 4x, so that'll disappear, and there's a minus in all of these that are left. Let's just factor that out. 3x squared plus 3x plus 4 all over x plus 1 times x minus 1. Now we might wonder, and we should think, I wonder if this would factor, and maybe it would factor in something that would have something that would cancel. So I may wish to just try factoring that very quickly. Are there any factors of 4? That would give me 3 in the middle there. It doesn't look like if I put 4 here and 1 here that would work. Maybe 2 and 2, no, 6 and 2, no, I don't think that's going to factor. So I think that what we'll do is we'll just leave that as is right there. Okay? And that would be my solution. All right, let's do one last problem here. This problem is posed as a function that we'd like to simplify by getting a common denominator, and then be careful about any domain restrictions. So notice in this original function, x cannot equal negative 2, and when I factor this denominator as x plus 2, x minus 2, you'll see x can't equal positive 2 either. So let's write f of x as 5 over 1, because I'm going to get a common denominator, and let's leave some space here to add in what I need. And then I've got x over x plus 2, and again I'll leave some space here. And then I got minus 8 over x plus 2, x minus 2. So notice that, again, you can see right here that x cannot equal plus or minus 2. That's a domain restriction in this function. I have a common denominator, and I've got an x plus 2 and an x minus 2 here. So I'm going to need an x minus 2 here to add in, and over here I'm going to have to add both of them, an x plus 2, x minus 2. So now I have a common denominator, and I can go ahead and combine those. So I'm going to get 5, and let's multiply these out. I can do that, x squared minus 4, so this is this numerator, plus x times x minus 2, that's that numerator, minus 8, and all of this is divided by that common denominator, x plus 2, x minus 2. Now I want to combine these, so let's distribute 5x squared minus 20 plus x squared minus 2x minus 8 all over that common denominator. Alright, so that gives me what, 6x squared for the squareds, and then I got a minus 2x and minus 28 all over that. Alright, so there's a common factor of 2 there. Let's factor that out. That'll leave me 3x squared minus x minus 14 all over the x plus 2, x minus 2. And again, I should probably just check. I wonder if this might possibly factor and maybe one of them would cancel. So let's just double check here. Let's see if it was to factor. Let's see, I'd get probably 7 and 2. Oh, look at here. If I were to put a 7 here and a 2 here, that would give me 6x and 7x, and that might end up with a negative x. So let's try our signs here. If I were to put a negative on the 7 and the plus on the 2, that would give me 3x squared and 6x for the outers, and minus 7x makes minus x here, and then minus 14. Sure enough, that did factor, and notice that one of those factors is now going to cancel. Alright, so this x plus 2 is going to cancel, and so my final answer is going to be 2 times 3x minus 7 all over x minus 2. And I just want to be careful. This is what it says about listing the domain restrictions. Remember, in my original function here, that x could not equal plus or minus 2. If you just look at the end result, you can see that x can't be a positive 2 because that would make division by 0, but you might be tempted to plug negative 2 into your end result, because you wouldn't notice that, and it would give you an answer, whereas up here negative 2 wouldn't work because you'd have division by 0 right here. Alright, so again, when I cancel these, I need to note that domain restriction that x does not equal negative 2, and that will be my answer.